It is here, the long-awaited prototype 3 of Phi's hand, and I think that this time I have made huge progress. I started out making the hand made of strings, and then gears, and then strings again. But this time I have found the ultimate solution. I can't understand why I didn't think about this before. So let's go through the problem again. I can already pull a finger using Kevlar string with basically no effort. And the pullback system is made out of rubber bands, which works fine right now. The problem arrives when the strings go through the wrist. When it goes straight, it works fine. But what I really want is the string to not get lengthened or shortened when the wrist rotates. And more importantly, when more than one string is in the wrist, they can overlap, which causes one string to drastically increase the friction of another string. But I think I found the best solution for it. I was thinking of things that already have solved this kind of problem, and then it hit me. Bikes. Bike handbrakes have already solved these kinds of friction. It uses a metal string that is pulled through a spring housing and a rubber housing on top. The inner housing, aka the spring, is the magic, because when it bends a little bit everywhere, which increases friction in the smallest way possible. Now, I did actually think about a similar solution like this before I thought of bikes. But in those I used PETG pipes as housing. But the problem with those, which I learned the hard way, is that they bend too much when the string gets tight. The result becomes that the PETG pipes bends upward or downward, or sometimes spins around, which actually increases friction in those directions instead. But why is that not an issue with the spring housing? Well, I think it's because the spring housing is way stronger than the PETG pipe. It also allows for the bend to get extra space, since the spring is hollow on the sides. So, I bought a bunch of bike brake housing and started building. And this is what I came up with. The housing goes through these helping paths, which I made as long as possible on both the knuckle side and the underarm side. The rest is pretty self-explanatory. I have servos with rollers that pull the strings, and I have strings that go out from the housings that pulls the fingers. Another thing that wasn't obvious at first is that I used 2 bolts on the side instead of 1 on each wrist axis. This allows the housing to take a different path freely. Another thing I realized also is that the housing always has to reach the end of its path, because if it doesn't, then that means that the distance between the servos and the fingers can change, which means I need larger rollers, and it's way harder to calculate. So what I did was just to cut them to fit when the distance is at its longest. And here we go. We are ready for testing. It works so well. When I bend the strings, they don't seem to have any issues. Now, of course, there are some bottlenecks left. Right now, I have 3 potential problems, which are when more pipes get added, they could stop each other from bending. The bend force that is needed to bend the wrist might be too high for one actuator to adjust. And the thumb now needs a new approach since the pipes now go diagonally along the thumb's axis. But those are problems for the next prototype. And honestly, I think this is a huge success. And I think this time it's not going to be a fake success that I got from the rollers last time. This time it actually feels like a solid solution. A few adjustments and improvements are probably needed, but I like this path with the spring housing, so I will probably double down on this solution. Alright, this is the end of the video. Thanks for watching, and thanks to everyone that has not forgotten about my channel. And for new viewers, don't forget to subscribe if you like this video. I'm planning to upload more often from now on. The plan is to release every other week if everything goes smoothly. I will also show some of my other projects that I have been working on other than the hand. But other than that, that's it. See ya!